Hey everyone, welcome. So today we're going to break down a term that you've probably been hearing a lot in the world of AI, cognitive computing. Let's get right into it.
You know that feeling, right? Where your computer is this super powerful machine. It can run a million calculations in a blink. But then you ask it to understand a simple joke or figure out what you actually mean, and it just, well, it doesn't get it. It's incredibly powerful, but man, is it frustratingly literal.
And this really shows you why. On one side, you've got that traditional rule-based computing. It's rigid, it's literal, and it's perfect for something like math, where there's always a right answer. But then on the other side, you have how we think. We're flexible, we understand context, and we're totally fine with things being a little messy or ambiguous. Cognitive computing is all about trying to bridge that huge gap.
So that leads us right to the big question. What in the world is this technology that's trying to think more like a person?
Okay, so here's the official definition. At its core, it's about building AI systems that don't just blindly follow a list of instructions. No, they actually try to simulate human thought. They're built to handle messy, uncertain information, to learn as they go, and to actually reason their way through a problem, kind of like we do every single day.
That all sounds pretty amazing in theory, right? But how does it actually work in the real world? Well, let's use a really simple analogy that makes it all click.
I want you to picture a store. Your traditional computer, that's the vending machine. Cognitive computing, that's the friendly, helpful store clerk. Now, they can both get you what you want, but the way they go about it is completely different.
Think about it. The vending machine follows super strict rules. You press button B4, you get chips. That's it. If you accidentally press B4 but you meant C4, well, tough luck. There are no exceptions, zero flexibility. This is exactly why a computer gets totally confused by a sarcastic comment or a blurry photo. It needs exact input.
But the store clerk, now they're on a whole other level. You can walk up and say something like, "Hey, I have a headache, but I'm also taking this other medicine. What should I get?" They get it. They understand everyday language. They might ask a follow-up question to clarify. They'll weigh the options for you and then give you a personalized recommendation. That is what cognitive computing is trying to be. So how does it pull that off? How does it act like a store clerk? Well, you can think of it as the Swiss Army knife of AI. It's not just one single tool. It's a whole collection of them. It pulls in language processing to figure out what you're saying, machine learning to learn from all the data it sees, and reasoning engines to weigh all the possibilities. It brings all those tools together to solve one complex problem.
I love this quote because it just nails the difference. A calculator's job is to find the one single correct answer. A cognitive system, though, is designed to look at a huge, messy pile of information and ask a totally different question. Given everything I see, what's the most reasonable interpretation here? It's a massive shift in thinking.
All right, enough with the analogies. Let's move from the abstract and look at how this technology is actually being used as a co-pilot in a really important, high-stakes field. You've probably heard of IBM's Watson from when it won on the game show Jeopardy, but its day job now is way more important. It's being used in hospitals and clinics to help doctors wrestle with some incredibly complex medical diagnoses.
So here's how that partnership works, and this is the really cool part. A doctor puts in all the patient's specific symptoms and their medical history. Then, Watson instantly plows through literally millions of medical journals, clinical trial results, and patient records, a job that would take a human being an entire lifetime. And finally, it comes back to the doctor with a list of possible diagnoses ranked by how confident it is in each one, and it even shows the evidence to back it up.
And this part is absolutely critical to understand. The goal is not to create an AI doctor. It's to give the human doctor a superpowered assistant, one that can handle the insane amount of data out there, which frees up the expert to focus on what we humans do best: judgment, empathy, and ultimately making that final critical call.
Okay, so let's zoom out a bit. Why does any of this matter to you? Well, because this technology really represents a fundamental change in how we work with machines.
For decades, we've thought of AI as being about task automation. Robots on an assembly line doing the same thing over and over. Cognitive computing is different. It's all about decision support. It's not here to do a task for you. It's here to help you make a better decision.
And we're seeing this everywhere. We just talked about doctors, but it's also helping lawyers sift through centuries of case law in minutes. It's guiding financial advisors by analyzing market trends, news reports, and a client's personal risk tolerance all at the same time. It's truly becoming a partner, not just a tool.
And this is precisely why, even as AI gets more and more powerful, human oversight isn't just a nice idea, it's absolutely essential. The AI is brilliant at providing the data, the patterns, and the probabilities. but the human provides the wisdom, the context, and the final judgment.
So, I'll leave you with this one last thought to chew on. As these amazing systems become less like vending machines and more like real collaborative partners, it forces us to ask a whole new question. It's not just about what AI can do for us anymore. It's about figuring out what our most important role is, working right alongside it.